everyone. So welcome to Exploration 2. This is your lesson video on exponents. Normally I would split the week into 2 videos, 2 lessons. I'm going to try and do it all in one this week and see if that cleans up your bright space a little bit. Hopefully makes your week smoother for your learning and everything you have to do. So just know that there are building skills in this video, just like last week when you had the second lesson building on the first. So if you need to pause this halfway through to go practice the skill and come back or come back to it later in the week, I will kind of give you that cue mid video so you know when to come back and you don't always have to watch the whole thing over again. And then let me know how it goes. Did you like last week's model better with the separate videos, or do you like this week's better with everything together? Just want to make sure that what I'm getting out to you through Brightspace is actually what is helping you learn for the week. So without further ado, let's get into our exponents. Exponents are kind of goofy looking numbers that have the little tiny number up in the corner. We're going to get into some of this vocabulary, and these are very important building blocks of math. We're learning it now. They're not going away. You'll see them pop up throughout your science eventually, through some of our science-based math later in the quarter. And when you get into real-world problems that have something that repeats, exponents are going to be your friend. So let's take a look at the vocabulary for an exponent. Get a new color. It's a little easier to see. Here we go. Okay, so when you have an exponent, you have the base, that is the big number, and you have the exponent. So we'll say an exponent of 4 for this one. So when we look at this in math and we see the big number with the little number, we call the whole thing an exponent because it has an exponent on it. But really, that term is just referring to the little tiny number up in the top corner. The base is the big number. So all exponents are made up of an exponent and a base. Now, this is really important to understand the difference, because if you don't, you're accidentally going to add when you should multiply, and that is the most common mistake I see all the time. So the way you read this is you have a base that is being multiplied by itself the amount of times you see in that upper exponent number. So if we have 2 to the 4th, it is not 2 times 4. This 4 is not on the line. He's up in outer space, up in the clouds. It's different. So the way you would read this and solve it would be that you have your 2, which is the base, multiplied by itself 4 times. So 2 times 2 times 2 times 2. That is what this is equal to. Okay, so this, you can think of this exponent as like an accordion, or if you have a slinky and you pull it in together and we want to know how many little loops are in that slinky, boop, it pops up to the top corner. So if we've got this 2 to the 4th expanded, there's 2. We bring that slinky back together, and the 4 goes up in the top. So again, that's how you would read this. You can say 2 to the 4th power, or 2 to the power of 4. Okay, so power is that word that I'm saying. Power. Let's look at another one. How would we read this one? Let's say we had 3 with a 5 up in the exponent. So your base is the 3, and it's being repeated. We're pulling that slinky out. Check your exponent up in the clouds is a 5. So we're repeating this 3 out 5 times. 3 times 3 times 3 times 3. There's 5 of them. So how would we read this? Again, using that power term. So 3 to the power of whatever your exponent is. Okay, so 3 to the power of 5. or 3 to the 5th power. If we're talking about these a lot, you'll hear it kind of condensed, and we might just use like a shorthand, 3 to the 5th, 2 to the 4th, 4 to the 7th. You can just put that TH on there once you understand that that exponent is the power. Powers of, you'll start to hear that come up more when we get closer to the end of the quarter. Okay, so now we've learned how to expand these numbers, see what they mean. How do you actually solve this? So I'm going to get rid of this bottom one here, and we're going to come back up and solve our 2 to the 4th. You just solve it in chunks. So you'll take your base, expand it out for the number of exponents you have. That's always step 1. So you're going to expand. Step 2, you multiply your chunks. So I'm going to do 2 numbers here and take 2 numbers here. I can multiply those chunks nicely. So 2 times 2 is 4. 2 times 2 is 4. Remember, there's still that multiplication sign in the middle right here. So I'm going to bring it down and now multiply this last chunk. 4 times 4 is 16. What if you don't like chunking? What if you just like working through your list? That works too. Let's take a look. Remember, we got 16. You'll see that as long as we keep our multiplication going, we'll still get the same answer. So we can just start from our first 2 and add on. 2 times 2 is 4. Add the next 2. So that's that guy right there. 4 times 2 is 8. Add the last one on. So this 2 comes from that guy right there. 8 times 2, 16. So if you had to answer, what is 2 to the 4th, or what is 2 to the power of 4? Boom, 16. Okay, so the most important part right here to keep you from making that common mistake is always expand first. If you don't expand, you'll accidentally add because you know your multiplication table so well, they just kind of pop up and sometimes they get in the way. So write it out. All right, let's take a look at another one. Get a new color. Come back. We're going to do 3 to the power of 2. Let's do 3 to the power of 2. So my base, find the base. It's the big one. Base is 3 right here. Now I expand it first. How many am I expanding it to? It says there's 2 of them. So times, count up your total, 1, 2. Good to go. 3 times 3, 9. So 3 to the power of 2 is 9. Okay, some other terminology you might hear that will make a little bit more sense on why we say it this way when we get to geometry. But if you have a 2 in the exponent, it is also called squared. Let's type in there. Come on, computer. Squared. So if you have 3 to the power of 2, you could say 3 squared. If you had 4 to the power of 2, you could say 4 squared. Just think of that square like finding the area of a square, right? Because if we had a square right here, it would be base times height. So if it was 3, you would have 3 times 3, which is the same as that exponent. Okay, so squared is just to the power of 2. All right, let's look at another term that you might hear come up as we solve another example. Let's go pink this time. Okay, let's say I have 2 is my base. My exponent is a 3. So first step, I always expand. You take your base and repeat it based on what's in the exponent. Two times 2 times 2. We'll go ahead and multiply out. 2 times 2 right here. I'm going to take the first ones. That gives me 4. Bring down this last one over here. Cross it off. I've used it. 4 times 2 is 8. So that means that 2 to the power of 3 is 8. Now, 3's also get a special term, just like we did for when they are squared or to the power of 2. So to the power of 3, we can say that something is cubed. Because if you were going to do a volume for a square, it would be multiplied out 3 times. So we can say 2 to the power of 3. We can say 2 to the third. Often, as you get further along in math, you'll hear more and more. This will be called 2 cubed. Okay, so cubes and squares are the only ones that get a special term because they go along with geometry. Everything else you would just say to the power of, like to the power of 4, to the power of 5. So just that reminder right here, 2 to the power of 3, aka 2 cubed. And if we had, let's use a 4 here, if we have a 2 in the exponent, we can call that squared. Okay, so at this point, you should be ready for the first half of the lesson this week. You can go on and try working on expanding some exponents. Next, I'm going to go into some things that happen when we have weird exponents, like when negatives pop up in there. Okay, as promised, negatives. So what happens when you see an exponent like this? Let's take a moment to analyze it. First thing, we still know it's an exponent. You see your base, that's the big number. Almost. Our colors are backwards. So our exponent is in purple. Okay, we're focusing on the exponent. So our base is the 4, our exponent is the -2. What happens when your exponent is negative? Not much. For the most part, you're going to solve this the same way. So you'll have a 4 and it's repeated, but we have to do something before we repeat it. Anytime you have a negative in the exponent, it just creates a fraction. So if you have a 4, it's going to end up in the denominator, and you put a 1 in the numerator. From there, you can put your exponent back on the 4. So it would just look like this. You keep your numerator and you do all of that exponent work in the denominator. 4 times 4 is 16. Okay, let's take a look at another one. So this time, switch my colors. We're going to have base 3 exponent. Let's stick with the 2 for now. So remember, we can call that 3 squared, but we're going to make it tricky. -2. 3 to the power of -2. So remember, for the most part, we can solve this the same way. We just need to put it in the denominator first. So notice Once I take that base and drop it down, the negative sign goes away. Now I've just got 3 squared, or 3 to the power of 2. So from here, I go to my next step. I keep my numerator the same. There's no exponents up there. And then I solve what's going on in the bottom. So that is my base repeated. 3 times 3. Solve whatever you see in there. I've got multiplication, 1/9. So you can see that basically your multiplication is coming out the same. 3 times 3 is always 9, but if it's coming from a negative, it's in the bottom of a fraction. Now, your exponents and the different things we have going on aren't always going to be 1. Right now, the only crazy thing we have is that 1 negative sign. So don't skip this step to just 1/9 is your answer. Work through it. Get rid of that negative exponent first so that you're working with your fraction. Solve the exponent in the denominator, then simplify. Get used to making that good habit now, because as they get trickier, you're going to need to work through each piece to see what's happening in your problem. All right, let's do one more. Let's say we've got 3 to the power of -4 this time. So I put it over 1. And I've got 3 to the power of 4 now in my denominator. So when I work that out, I will have 1 in the numerator and 3 times 3 times 3 times 3 in my denominator. So if we work that out, my 1 stays in the numerator. 3 times 3 is 9. 3 times 3 is 9. Bring down my little multiplication. 9 times 9 is 81. So 1/81. A good way to check yourself is if you ever see a negative sign in your exponent at the beginning, you know you need to end up with a fraction. If you don't get a fraction at the end, something went wrong. All right, let's look at some other rules for just weird things that we can see happen in our exponent problems. Now we're going to get into our exponent rules and how to handle it when you have long expressions with weird exponents running all over the place. How are you supposed to simplify that? So all of the rules that we're about to go over are really just a combination of 2 math kind of theories, skills that you have already been using, and now we're putting them together with a new skill to be able to do some really cool stuff. So the first skill that you need to remember is your distributive property. So that is this example right here that I just highlighted. Your distributive property is something you can use whenever you have a term, like a number or a variable, outside of your parentheses, and we need to bring it inside to multiply by each term. So that's distributing it, right? Like if you're playing cards, you distribute your cards to each person at the table. That's kind of what we're doing. The x plus 2 in the parentheses are the terms that are sitting at the table. The 6 is the dealer, and we're going to distribute that 6 to both terms. So that's where they take it in, 6 times x, take it over, 6 times 2, and then just clean that up. So 6 times x is 6x, 6 times 2 is 12, and that is the final answer after you distribute. We are combining that with PEMDAS. So you might remember PEMDAS as just that acronym. You might remember it as please excuse my dear Aunt Sally. These are just things that help you remember the order of operations. So whenever we have more than one operation in a problem, an exponent, division, addition, subtraction, there's more than one thing happening, we have to do them in this order or our answer will come out wrong. So you have a reminder here in the image that I'm going to be talking about. This is the same image and notes that's pulled from your lesson slides this week. So you can see it nice and big over there, and go ahead and review it whenever you need to. So the order that we always have to go through math problems in is first parentheses. So whatever is attached to that parentheses, you have to handle first. Then you move on to solving your exponents. Then you can multiply or divide whatever is left over. And very last, you can add or subtract whatever is left over. So all of these rules in your table are showing you the definition. So the rule that you can apply to anything, just plug in your numbers, and then an example of what that looks like with your numbers once you apply them. And when we break this down, you'll see that really we're just taking our distributive property, distributing our exponents, and then moving on according to PEMDAS. As the rules get longer, we start combining things. So the first thing that you need to know that's specific to the exponents is your product of powers rule. So your A right here is just standing in place of any base, any big number. For example, we're going to make that a 5. The M and the N are just standing in place of whatever your exponent's going to be. It could be a 2, it could be a 3. In this problem, they're giving you a nice ugly 1, so you have a 1/2 in the exponent. Your product of power rule says that whenever you have two exponents being multiplied that have the same base, you just combine them into one base and add the exponent. So let me show you what that would look like. Get a better color. All right, I'm going to go in blue. So let's say I'm going to do the product of power rule for this problem. So I have base 2 with the exponent 4 times base 2 to the power of 5. So the trick to be able to use this rule is that my bases match. They are both 2. So instead of having to have 2 terms in my problem when I'm trying to simplify things, I can change that to just be a single 2. And then if I check my rule up here, I have m plus n. So that means you're adding your exponents. So I take my exponent, that first one is a 4, and I add it to the second one. That's a 5. And now I'm at my addition. So now I can take that 2, 4 plus 5, 9. So if you were to solve this all the way out and you did 2 times 2 times 2 times 2, right? The exponent for the 4 and the exponent for, you would have this total of 9 2's, which is what you have in your answer. So that's just a nice way to simplify it. Math always works this way, so you can memorize this rule or you can do it intuitively. Okay, let's see if I can erase, and we're going to talk about the next one. Erasing very nicely, hopefully find a faster way to do this. Okay, product of a power. Sorry, power of a power. So this is when you have one base, but 2 exponents. So like your example, let's say our base is going to be a 3 to the power of 2. So that's that 3 squared. And then there's parentheses around it. And you have another exponent out here. So this is just saying that you have an exponent again. So it would look something like 3 squared times that just 4 times, right? Because our exponents repeat your base. So it's like a double exponent. Now, instead of having to write this all the way out over and over and over again, our rule right here tells us that we can just change it to 2 times 4 in the exponent, and then we can do it all at once. So your power of power rules means you have a 3, right? That's your base. And when you have the two exponents, one inside the parenthesis, one outside the parenthesis, you just multiply them. So you keep your base, and then when you've multiplied your numbers, in this case 2 times 4, we get 8. Okay, so that is your power of a power rule. Okay, now what if there's 2 bases inside those parentheses? There's 2 bases. It might look something like, let's say we have 2 times 3, and then we close that up, and we have one exponent on the outside. This is where you can go back to that nice distributive property. It's the, oops, I should have given you a number there. There we go. So let's say our exponent is a 5. If you have an exponent by itself sitting outside a long parenthesis group like this, you can just distribute it through. And that's what the rule is telling you right here. So the A and the B are telling you that you have 2 different bases. And the M is telling you that you have this same exponent. So they put the M on the A and the M on the B. So I'm going to do the same thing. I'm going to distribute that exponent in. So I'm going to end up with 2 to the power of 5 times 3 to the power of 5. And that's it. Now that's something that I would be able to solve, right? I could find 2 to the power of 5. I could find 3 to the power of 5, multiply them, and simplify all the way through. Okay, I'm going to erase. So it'll take me just a moment, and then we'll do the next one. All right, let's look at our next one. So next we have a negative exponent. We looked at this a little bit when our whole base was going into the bottom of a fraction. Well, the same thing here. They're just showing you what it would look like when it's written as a rule. So you have your base, your exponent is negative. We just drop it to the bottom of a fraction. So let's say this is just like what you saw up above. If we had -2, that's the same as putting 1 in your numerator and then just dropping it down and solving the exponent on the bottom. So I showed you earlier in the video, so we're not going to do this one again. A 0 exponent is kind of nice because it's always the same. No matter what your base is, if you have a 0 in your exponent, it's telling you that you have 0 bases. So it's just 1. So 213 to the power of 0 equals 1. 4 to the power of 0. 5 to the power of 0. 8 to the power of 0. Doesn't matter. Always 1. If you have quotient of powers, so this is if you have the same base, but one is on top and one is on bottom, just like how that fraction looks like the opposite of the multiplication, it's going to work out pretty similar. We're just going to do the opposite operation. So let's say that we had 2 to the power of 3 over 2 to the power of 2. You keep your base. And now, since it's division instead of multiplication, we're going to subtract our exponents instead of adding our exponents. So you take your top exponent minus your bottom exponent. Oh, I'm running out of room. Let's move that over. It's not going to let me. Okay, I'll write it somewhere else. So again, I'm taking my base, which is 2, the top exponent minus the bottom exponent. So 3 minus 2 is 1, right? So then in your final answer, you keep your base and your exponent just becomes what you solved. So 2 to the power of 1. And again, power of a quotient, they're getting a little similar now. This is just like how we did the distributive property with power of a product. So your A and your B are standing for two different bases. So we can say I have a 4 and a 5 inside the parentheses, and then the M is showing that you have one type of exponent. So that one exponent, let's say it's a 2, is hanging out here. We just distribute it into each one and keep it as a fraction. So 4 to the power of 2, aka 4 squared, distribute to the bottom. The 5 gets the 2. And now you're simplified. Now you're at something you could solve. If a problem asked you to solve it all the way through, you would just work out your exponent for the top, work out your exponent for the bottom, right? So that would be like 16, right? 4 times 4, and on the bottom, 5 times 5, 25. And then you would check to simplify, okay? So you can return to this table until you get more comfortable. Practice using these rules on the IXL skill that's linked in the slides. We'll do practice problems with these in Zoom. And on your assignments this week, you'll try to start noticing some patterns. So like the product of powers and the quotient of powers. That's when you have the same base, different exponents, and you're pulling them together. When you have power of a power or power of a quotient, that's when the parentheses come in. So you're either you have one base and two different exponents. So you're either going to multiply, subtract, or you're distributing. And then this negative exponent and the 0 exponent are just ones that we can remember. 0 is always 1, negatives are always a fraction. So I'll kind of put these lines here for you to see. This is kind of where your table starts to repeat. So this is when you're dealing with multiplication things, and this is when you're dealing with division things, but they follow a similar pattern in the rules. Again, you have additional videos this week, and if you have an IXL account, you can watch the tutorial and the example in there. I'll see you on Zoom, and I can also see you for a study hall. Good luck this week. Hope you're ready to get started. Let me know if you have any questions.